All right, some people had some issues with numbers 5 through 9. I'm going to blow through these really quick and then maybe do some notes on 3-4 for you for today. Look at the relationship. Which two functions have the same rate of change? Some of you have said, what is rate of change? Rate of change has many different names. It's slope. It's change in y over change in x. It's the letter m in the formula y equals mx plus b. It's rise over run. All of those are different things. Ooh, the formula to find slope or the rate of change is y2 minus y1 over x2 minus x1. These are all things you want to just throw into your notes because these are things that we have worked on and done previously in the equations. Now, in these four parts, A, y equals mx plus b, like I said, y equals mx plus b, right in here, that is the rate of change. It's the slope. So in all of these, all you're looking for, the 5, the 4, the 0.6, and the 0.5. These are what we're looking at. Which one has the same m, slope, rate of change? Well, this one has 0.5, this one is a 4, this one has 0.6, this one is 0.5. So D and A have the same rate of change. Not a horrible one there. Which two have the same slope? Now, number 6 takes a little bit different journey. Make sense and persevere. Glenn compares the rates of the change in two linear functions are presented in the different forms. For a linear function in the form of y equals mx plus b, how does Glenn determine the rate of change? How does Glenn find the slope? Now, these are all ways to do it. If you graphed it, rise over run would work the best. Remember, count up and over to create that. But if they give it to you like this in a bunch of points, how do I take that information and turn it into rate of change? Well, there's two ways. Okay, the x values, it's the change in y over the change in x. You could take any two values for y. Let's say we take 22 and 20. You can just subtract those two numbers. It doesn't matter what order, just as long as you're consistent with their x values. So if you subtract 22 minus 20, you better make sure you subtract 1 minus 2. Or if you do 20 minus 22, you better make sure you do 2 minus 1. As you can see here, I've done it two different ways. 22 minus 20 equals 2. 1 minus 2 is negative 1. Your answer is negative 2. Same thing on the bottom. You look at the bottom one. Ooh, it's getting blurry. There we go. If you look at the bottom one, I just reversed it. I made it 20 minus 22, but I also reversed the bottom part, the x values, as 2 minus 1. Guess what? Makes the same stinking number. It tells me that using this right here, I can find the slope by just taking those numbers and subtracting, and it makes a negative 2. Now, I could take any pairs of these numbers. I could take 16 minus 18, that's negative 2. 4 minus 3 is 1. Oh, negative 2 over 1, same thing. 18 minus 20 is negative 2. 3 minus 2, oh, 1, it's negative 2. The slope is consistent. That's a constant of proportionality, a constant rate of change. These are all terms that we've used for slope in this problem. So for number B, or number A of part 6, how does Glenn determine the rate of change? Just showed you right there. Any of those ways. You could use any of the sets of numbers just as long as you're consistent subtracting. Now, how can Glenn determine the constant rate of change of the linear function presented in the table at the right? What is the rate of change? Now, that's what I just did right there. I showed you that just by taking any two pairs of the y's and x's and doing the subtraction, it's constant. 16 minus 18 is negative 2. 4 minus 3 is 1. Negative 2 over 1 is negative 2. Same as everything that I did right in here. So that means even with these numbers, heck, I could take these and these. 16 minus 22 is negative 6. 4 minus 1 is 3. Negative 6 divided by 3, negative 2 again. So I have just shown the constant of proportionality. Okay, the constant rate of change. Constant means the same. Rate of change is the slope. So the same slope. They're all the same in that problem. Okay, so that's number 6. Number 7, ooh, critical reasoning. The table to the right and the equation y equals 8x plus 5 describe linear functions. A student states incorrectly, they're telling you right now, this person screwed up, that the initial values of the functions are equal. Compare the initial values of the functions. What mistakes did the student make? Okay, now the initial value for this student, 0, 8. That means at 0, he's saying if I make x 0, y is 8. If I make x 0, what should y be? Think about it. Correct, it should be 5. That's the mistake. This person looked at this and goes, oh, whatever I put in for x, I just add it to 8. What was 0 plus 8? But they forgot about the plus 5 in there, and they forgot that it's multiplication with the x. So there's a multitude of errors that this person made within this problem. You just need to know, all you have to do is substitute the 0 in for the x. 8 times 0 is 0, plus 5. That should have been 5. I changed the x into 1. 8 times 1 is 8. 8 plus 5? Correct. 8 plus 5 is 13. They're wrong all over the place. Bad, boo. There's a multitude of errors. There's a bunch of different ways you could have explained. They didn't give this person a name because they were so bad. So, now the bottom ones are a little trickier. Not really. The equation 4x plus 60 and the table each describe the linear function. Compare the properties of the function, select all that apply. Now, they give you the chart here, 10, 60, 20, 80, 30, 100, 40, 120. You can find the rate of change, make sure it's consistent. 80 minus 60 is 20. And, ooh, check that. This is interesting. Put the 10 in. 40 times 10 plus 60. Does that work? 4 times 10 is 40 plus 60 doesn't equal 60 in my book. Okay, so I'm telling you right now, the equation, just in the first part of it, you put the 10 in there for the x, you put the 60 in there for the y. 4 times 10 is 40 plus 60. Y should be 100 right off the bat. Boo. Okay. The linear function described in the table has a greater rate of change. Okay. So my rate of change, 80 minus 60 is 20. 20 minus 10 is 10. And 20 divided by 10 is 2. My rate of change up here is 4. My rate of change down here is 2. Does the linear description in the graph and this, is that bigger than this? No. Okay, the linear function described in the equation has a greater rate of change. Oh, wait a sec. I made a mistake. Okay, this has a greater rate of change. So linear function described in the table has a greater rate of change? No. Linear function described in the equation has a greater rate of change? Yes. The rates of change are equal? No. The linear function described by the table has a greater initial value. Okay, if this is going up by a rate of change of 20 and it's going up by 60 to 20, all of this, if I put 10 into this one, that's my starting point is 60. This is definitely below 60. It's only at 60 after 10. So the linear function described in the table has a greater initial value? No. Linear function described in the equation has a greater initial value? Yes. The initial values are equal? No. Okay, makes sense? Let's go on. Jeff saved $500 from a suburb job. Now this one has a multitude of different answers that you can get for it. Jeff saved $500 and he spends $12 a week during the school year. Melissa's is shown in the graph. Compare the two functions. There's a lot of stuff that you can pull from it. Number one, Jeff started with less money and he's spending more. Melissa started with more money and is spending. How do I know Melissa's spending less? You're right. She's only going down by $10 every week. She's going down by 10, from 510 to 500 to 490 and so on. Jeff started at 500 and he's going down $12. So he starts with less and spends more. Jeff sounds like a dumb mathematician. All right. So that should help you with numbers 5 through 9 for the worksheet. Ah, earthquake. All righty. So I'll be coming out with another work, the 3.4 or 3-4 today. That's what we're supposed to work on today and tomorrow. We'll come over with some stuff to help you out with 3-4. It's a lot of this. Y equals mx plus b, rate of change, graphing, doing that type of stuff. maybe even writing equations from the information they give you. So there's some information that you're going to need to do there. We'll go over it all. I'm going to go over the formulas later today, but I wanted to go over numbers 5 through 9 to help people out. Alrighty, there you go. Bye.